Cool. So I'm Rob Kaufman. I prefer he, him, his. And I'm here from Software Served by Scientists to talk to you about IIIF, PDFs, and you. Back in 1995 is the first time I remember encountering PDF, and I really distinctly remember it because I was buying like a lot of bargain bin video games back when you had to like reboot your Windows computer from a floppy into DOS mode to play them. And they would always have these PDF manuals, and they were just awful, right? It was a terrible format. It was really hard to get it to open. It was slow. There's no way this thing ever catches on. And I remember very, very distinctly talking to my dad about how PDFs were a dumpster fire and we're never going to go anywhere. And yet they are everywhere. We see lots of collections that have PDFs sort of mixed in, many collections that just have huge sets of PDFs. We pass around PDFs to sign things digitally now. Like PDFs are very ubiquitous in the world today. So why is displaying PDF in a IIIF or other Samvera application hard? There are a couple of factors. One, PDFs are both a raster and a vector format, which means that they're sets of coordinates for drawing the drawing or letters, as opposed to a bitwise format like a JPEG or a PNG file, or a JP2 or a TIFF. They are compressed. There is currently an ISO standard that is supposed to tell you how to compress them, but it turns out that there's enough wiggle room in that standard that you can use one of a few compression algorithms. And whenever you get one of a few, that means you have implementations of PDF readers that don't, read every PDF that's created. PDF is still kind of proprietary. In 2008, in 1998, Adobe started an ISO standard around the PDF file format, and they, though they own the patents for PDF, they license them free to anyone making a PDF viewer or other PDF creator, as long as those PDF manipulating programs follow their PDF specification. Yet, historically, there have been many different PDF writers, especially Adobe Acrobat PDF, that add extra feature layers on top of those PDFs that make them, that provide vendor lock-in and don't really quite follow the standard, or, add stuff on top of the standard. And that causes some real issues, frankly, with reading and displaying them. PDFs are multi-page, and we'll talk a little bit more about why that's especially challenging in IIIF a little further down. And then the other thing is that PDF is native on most systems. So Windows, Mac, iOS, Android, the Wii U all come with a built-in PDF renderer application of some kind. And so in the browser, rendering PDFs has never gotten great, because you're supposed to just download them and open them. And that ability to do that and have a much better experience than what you get in Safari or Chrome or Firefox means that there's not a lot of pressure to make those in-browser PDF viewers better, frankly, because many people don't use them or even know they exist. So what are some ways to display PDFs, and specifically here a IIIF app, though this is generally applicable across all web applications? You can just download them. If you download a PDF, oftentimes it'll open automatically. That depends on the user's settings. It's nice to respect the user settings when we can. And frankly, I think that that is a perfectly reasonable way to handle a PDF. You're letting the user's computer do what it wants to do with the PDF, and kind of trusting the user to have their system set up in a way that now allows that. Then there's opening it in the browser. These aren't necessarily a bad experience, though they are often not a great experience. You can open it in a new window. That can help that experience a little bit. Though then there's accessibility issues because you're jacking the window focus. There are, some pros and cons to opening it in the browser, though that is something you can supply a few headers and open them in a browser. Then there is a big set of various JavaScript viewers for opening them. This is fine for 4 or 5 page PDFs, but browsers, especially Chrome, Safari, Firefox, the main web browsers, are pretty heavily sandboxed in today and tend to be resource hogs. And so opening the PDF in JavaScript is not the most efficient way to handle it, and can be pretty rough on the system and on the user's computer if they are opening it in opening a large PDF, something in the 500-600 page or more range. And then you can potentially do full PDF in the IIIF viewer, and we'll talk a little bit about that. And then there's this idea of breaking the PDF up into images for use in a IIIF viewer. And that's kind of where we're going to get to in the end, but you have to bear with me for a minute while we get there. So I'm not going to talk a lot about these other methods because I want to get into the IIIF part, because that is the place where I think things get the most interesting. So what is IIIF and why do we want to use it? We've had several talks already here at Connect this year about IIIF, so I'm not going to spend a ton of time talking about what it is, but essentially it's a standard for displaying or describing the display of images, videos, audio, other high resolution objects in a way that is both scalable. So you can say, oh, I want just a tiny corner of this image at a very high resolution, or I want the whole thing at a small resolution. I want to turn them. I want to invert the colors on them. There are like lots of options you can send to IIIF. But it also with some metadata around that, you can have what do I want to say? You can say here's the attribution, here's some description metadata, lots of other things you can add to the IIIF manifest that really help round out the image that people are seeing in a viewer. So it provides it enables complex viewers. So you can do what I like to call data remixers. So the idea that you're taking multiple IIIF manifests and then you're able to look at things side by side can be really valuable. The idea that we can bring transcripts into videos or audio, I think, is really powerful. Lots of just really cool technology around these IIIF viewers. They're becoming a very common standard and are really important to open access. So more and more often, institutional repositories have IIIF manifests for their assets that then allow us to kind of have this lingua franca of ways that we can view or create viewers and data remixers around them. So if we want our PDFs to be viewable in IIIF, we have basically 2 options. There's the PDF, full PDF in the viewer. So this idea renders the PDF in the UV. It's the only implementation that I am currently aware of is Apache PDF box through the Cantaloupe image server. So Cantaloupe is a very powerful and popular IIIF server, and it can support PDF out of the box with reasonable performance in version 5. Version 4, the performance was great for anything less than 10 pages and abysmal thereafter. They've done a lot of work to improve that across the board. You are then able to see in a IIIF manifest the link to the PDF as a canvas, and then it renders them in the UV. There are, however, a few downsides. This is not really part of the IIIF standard. It does not currently work in Mirador or really any other viewer that I found beyond the universal viewer. It is, and in the UV, you have to add an additional JavaScript plugin in order to get it to work in the UV. It doesn't work out of the box even in the UV. It's not widely supported. It does require you to use the Cantaloupe image server. None of the other IIIF implementations that I'm currently aware of support PDFs out of the box. It is still slow for large PDFs, and it does use Java to process those PDFs. Uses Java is programmer code for takes up all your memory. So it's kind of a resource hog. And then I think more existentially, there's a problem with the fact that we now have 2 page layout hierarchy tools, both the IIIF presentation layer and the PDF itself, that are kind of warring for control over the layout of the pages. And it doesn't currently support search in the viewer. So that is kind of a drawback. And it can only display a single PDF. So one of the things we found in one of our implementations early of this process is that if you displayed a PDF in IIIF, you could not also display images or videos. So one of the cool things about a IIIF manifest is it can display multiple documents. And when you do a PDF, it sort of takes over the UV and it won't display anything else in the manifest. So it's kind of PDF and nothing else. You can't kind of add other things to it, which is a bummer. This is probably a bug in the UV and is probably surmountable, but at the moment, all the implementations I've seen of this have this limitation. So what if we break the PDF up? We've talked about this in the Slack channel and the dev Slack channel a few times. It's come up as a feature request to be able to display PDFs natively in our IIIF viewer. So we had a lot of conversations about this over the last few years. So the idea here is that each image is then supported by the normal IIIF process. So we're taking a PDF, we're going to break it up into each page being its own individual asset, and then serve those assets. We can then adjust resolution at that point if we don't want to, maybe our PDF is super high resolution and we want to only serve, up to a limited resolution. We could watermark them at that point if that's a requirement for us. There are a lot of possible things we can do once we've said, okay, we're going to take them out of being the PDF. It is true that Tesseract, the most common OCR library used by for large preservation projects currently, requires, if you're going to OCR PDF, that you break it up into its component pages, one for each image, and then you scan those. So that's a great time to grab those images and just kind of keep them. Then they're searchable, remixable, and available across all viewers. The PDF can still be retained for download or preservation. Like, you don't have to throw that away, but when you're displaying is actually the images of the pages inside the PDF. The newspaper works gem. So I was really shocked and very pleasantly surprised to find that there was a gem in Samvera Labs that did this PDF work already. And so we've been utilizing it on several projects. It automatically splits the PDF up into its common component pages. It creates both TIFFs and JP2s of each page of the PDF, and it handles OCR with Tesseract. This particular gem is very focused on supporting newspapers as a whole concept. And so there are a couple other complex tasks that the newspaper gem does. It brings in several sets of work types. It handles some complex layering so that you can have a like a newspaper publication, and then you'd have newspaper issues, and then each of those newspapers has newspaper pages, and there's some complex relationships that occur because of that. It does kind of do everything for everything when it comes to the assets that you would attach to these work types. So for example, when you attach a PDF, it's going to take that PDF and it's going to split it up into its component pages. It's going to make a JP2 and a TIFF, and I think a JPEG of each and every, or a thumbnail of each one. And then it's going to OCR it and make that OCR data available in like 3 or 4 formats. And then create a single page PDF of that image that it created. So it's doing a lot all the time. And because of that, it can be kind of slow to process the derivatives. Now, this can be fixed pretty easily by just making it more easy to adjust which of the various derivative processes you want on at a given time. See Jeremy's talk that literally just happened, because that is a lot of the work he was just talking about. We've been using this newspaper gem for several haiku applications recently in order to do this process. It's been working really well for us, honestly. Being able to then have the search in the viewer, being able to see the images, those are all really great things. We have had to make some modifications to the way we display, in a normal hierarch show page. There's sort of the UV up top, and then there's the list of all the attached files, and it can get kind of redundant. So we've been doing some work to kind of make it easier to display what you do and don't want to see there. And so it is important when processing a large set of PDFs that you I'm gonna slow down for a second. I've been talking way too fast. Okay. It is important that you process what you need. We realized for a project that has high resolution JP2s, and the JP2s are sort of the lingua franca that this application needs at the end, that we were also creating TIFFs for each and every one of those, which was wasteful. Now, if you were starting from scratch and you don't have JP2s, or you don't have an image format that you're already sort of married to, make pyramidal TIFFs. Pyramidal TIFFs are the fastest to serve from the IIIF servers that are available today, and are kind of the most versatile thing that you can create. So make that the thing you use if you have an option. Processing, splitting, and OCRing a large set of PDFs takes some serious CPU time. So we have a collection of, I want to say it's 55,000 PDFs that are very high resolution. Their average page size, we were originally told, was 20 or so pages per PDF. There were a bunch of ones that were 1, and there were a few that were 300 or so. It turns out the average page size of the actual collection is about 325 pages across the collection, now that we've blown them all out and understand how many pages they all actually have. It takes a long time to create the derivatives for 2 million plus records. It just takes a lot of CPU power. You're going to have to expect to kind of deal with that. Another big gotcha we found is that if you have Tesseract installed at all on whatever server, or in our case, Kubernetes pod, you're running fits in to do file identification, which is a normal part of the Hyrax process. If Tesseract is detected, it will OCR the files with this thing called Tika, which is a Tesseract wrapper or in Java. So when we would go to see what size an image is, we would OCR the entire thing and then completely ignore that data. Then we would take that image and we would later pass it to Tesseract to OCR it again. That costs a bunch of time, quite frankly. In the end, this process had a weird loop in it. So we would then take all the images we created and split from the PDF, put them back together in a new PDF, and then OCR that by splitting them apart again, OCRing each page, throwing all of those away and creating again. It was a whole big mess. We were spending a lot of extra unnecessary time. So be aware that this Tika, like, it's not that if you enable it in Fits or you configure Fits to use it, it's like if Tesseract is detected as being installed on the system, Fits just does it for you without asking. And it, 100x's the time it takes Fits to process a file. What are our next steps? We've been doing some initial work talking about, how to split up the functionality of the newspaper works gem. I don't want to disturb that gem, quite frankly, because it does what it's supposed to do very well, but possibly making this derivative part a dependency of it so that we can use the dependency code without it, or possibly refactoring hydro derivatives to include some of these derivative process things out of the box and then make them much easier to turn on and off at a work type level. I think could be a really powerful and useful contribution to the community. We are already working on getting these features back into Haiku. Once we're finished with this round of performance improvements, we're going to be contributing that work back, and it should be in a future work release of Haiku. At that point, if you upload a PDF, you will get it displaying in the IIIF viewer kind of automatically. We wrote a AWS Lambda for OCRing large collections of images and breaking up large sets of PDFs. We're calling that Space Stone because it's Tesseract in the cloud, and that sounds fun. That should be appearing in Samvera Labs very soon, or may already be up there. I don't remember whether I pushed that code or not. I did mean to do it before this talk, so look for that soon. And then Jeremy has been doing some work, which he talked about recently, about making it easier to kind of turn multiple derivative types on and off. And I think that can be something that maybe gets all the way back to Hyrax, and I think would be really useful. And then getting serverless IIIF support out of the box for Hyrax. Running Cantaloupe is expensive. Running the serverless IIIF is substantially less expensive and faster and easier. And so all those things combined make it really attractive. It does have some kind of limiting requirements, like you have to be running an AWS. In order to do the hierarchy support, you have to be using something that makes your images available from an S3 bucket. We found that Fedora, if you have your Fedora backed by S3, that we can use that kind of out of the box. And so that'll be for what this initial implementation does. All the ones with asterisks next to them, which is basically most of the slide when it was all said and done, are already in progress in one form or another. The serverless IIIF support was recently expanded to allow for JP2s, and we're working right now on kind of getting a default hierarchy configuration and some simple instructions to deploy that process. I will not advocate for serverless IIIF being the default and replacing RIF. That is not what we're talking about here. We're talking about making it a clear path to enable it should you want to. And that's mostly because Lambdas take a little more understanding to work, and because you have some limitations on what kinds of ways you can store your files to make them available to the serverless IIIF server. And that's it. This is where I think we should get to. Frankly, PDFs are sort of like having the authors ordered. Is something that comes up for us over and over and over again in conversations we have about hierarchy and haiku. And so I'd really like to see this get into the mainstream so that everybody can benefit from it. Does anyone have any questions?